Okay, now that we've finished two-dimensional figures, we're going to move into three-dimensional figures. So, two things we need to do today. Classify three-dimensional figures according to their properties, and then use nets and cross-sections to analyze those three-dimensional figures. So, we've gone through all this two-dimensional stuff with all of our figures. Now we're going to look at polyhedrons or three-dimensional figures. So, first thing that I want to do is I want to pull up a definition for us. Hey, you get to see the Bobcat Fast auction on the way here. The definition. Okay. So definition of a polyhedron. Great definition in Wikipedia. Says that a polyhedron is a geometric solid in three dimensions with flat faces and straight edges. Okay, the word polyhedron comes from the classical Greek poly, meaning stem or many, and hedron, form, base, seat, or face. Okay, polyhedron is a three-dimensional example of the more general polytope in any number of dimensions. Okay, so what you need to know, remember, it's a geometric solid in three dimensions with flat faces and straight edges. Flat faces and straight edges. Okay, all the things we see today are not going to have straight edges. Some of them have curved edges, so they don't apply as polyhedron, but they apply as three-dimensional figures. Okay, so three-dimensional figures or solids can be made up of flat or curved surfaces. Each flat surface is called a face. Okay, the intersection of the two faces is called the edge. And the intersection of three or more faces is called its vertex. Okay, so a prism. So we have a table in front of us in our notes, and we're going to fill out each of those with the figure, the picture, and then a definition. So a prism is formed by two parallel congruent polygonal faces that are called bases, connected by faces that are parallelograms. That includes rectangles and squares. You can remember a rectangle is a parallelogram and so is a square. So if we look at this, this figure here is one of my bases. That base is a triangle for this figure. Okay? The others are rectangles. Okay? Those rectangles are our faces. The triangles are our bases. Okay, so looking at these figures here, I've already kind of drawn on them. Okay, how do you tell where the base is in a prism? Okay, the base of this prism you see here is a triangle. Base of this prism that you see here is a hexagon, and the base of this prism that you see here is a pentagon. Okay, this one here is a hexagonal prism. Okay, remember prism has two bases. There's some figure, and then those other faces that are on there are rectangles, squares, parallelograms. Okay, sometimes we'll run into the situation like we run into right here, where the bases and the faces are the same. They're all squares, and we know that to be our cube. Okay, this one the bases are triangles and the faces are rectangles. Okay, this one here the bases are hexagons. This is an oblique figure, so the faces are parallelograms. Okay, this one here is a star. Okay, it's still a prism. The faces of it are stars, and then, or the bases, excuse me, are stars, and then the faces are rectangles. Okay, next figure is a cylinder. Okay, a cylinder is formed by two parallel congruent circular bases and a curved surface that connects the bases. The best example of a cylinder and how it works is that of a Campbell's soup can. They have on the Campbell's soup can, if you see this red line here, a label that can be cut off of the soup can and opened up into a rectangle. If you look at the length of that rectangle, the length of the rectangle on that cylinder, on that Campbell's soup label, is the circumference of your circle. It's a fabulous thing. I love it. Hope Campbell's Soup never stops making their cans that way. Okay. Pyramids are our next one. Pyramid is formed by a polygonal base and triangular faces that meet at a common vertex. Okay, again, the base down here is a square, and the faces are always triangles in a pyramid. Okay, here's two different pyramids. This one has a base that's a triangle down here. Okay, this one has a base down here that's a pentagon. Cones. Cone is formed by a circular base and a curved surface that connects the base and the vertex. Okay, so we have a base that's a circle, okay, and it meets at a vertex point. Okay, so those should be all the ones that you've drawn in your chart. Okay, the next thing that we're going to talk about is a net. A net is a diagram of the surfaces of a three-dimensional figure that can be folded to form the three-dimensional figure. To identify a three-dimensional figure from a net, look at the number of faces and the shape of each face. So what I'm doing is I'm taking a two-dimensional net, folding it up to make a three-dimensional figure. Okay, all the figures you see here you have on your sheet. So the first one, as we fold it up, becomes for us a cube. Okay, becomes for us a cube. The second one that we fold up actually becomes a cone. We have a circular base, and then the semicircle comes around and helps for us to create the cone. Okay, this one, when we look at it, we have 4 triangles. They all look the same. Okay, I have a base, okay, and then I have 3 triangles. I fold them up, I get a pyramid. Okay, the last one is a cylinder. If you look at it, for cylindrical, it has a rectangle and circle for the 2 bases, so it forms for us a cylinder. Okay, cross section. Okay, a cross section is the intersection of a three-dimensional figure and a plane. Three-dimensional figure and a plane. Okay, and if you pay careful attention to this, the best way to look at this is if you think about those big barrels of cheese that they have at the H-E-B. They have this big round, huge thing of cheese, and when they cut through it and slice through it, we don't get a round piece of cheese. We get a rectangle. Okay, we take a block of cheese and we cut something out of it. Even if it's a circular piece of cheese, when we cut it out, we get a rectangle. Okay, so this cross section here is parallel to the base, which is a pentagon. So the cross section here, when I cut through it with my plane, becomes my pentagon. Okay, this one here, when I cut through it, cuts through at the very top. It cuts through the vertex. So the cross section of the plane and the cone here is actually just a point. Okay, this one here cuts through perpendicular to the base, so it forms for us a triangle. Forms for us a triangle. Okay, this one here cuts through parallel to the base, a little more difficult to see, but as you can view here, there's the triangle that's been that's its cross section. Okay, this one here, okay, as you cut through, you're cutting through parallel to the base. It's a pyramid sitting on its side. Okay, so you've got for yourself the rectangle. Okay, so that's all that we have on those. Okay, your job is to make sure that you know all that vocabulary for tomorrow. Okay, we'll work on some problems tomorrow, and then we're going to talk about other ways to draw three-dimensional figures.